Good morning, dear students. My name is Radhesya, and we are discussing in this video need of modulation. So we have original signal. So why do we not send the original signal to the receiver? Why do we do a modulation in the transmitter stage and then transmit it to the receiver? So what is the need of modulation? So the first point is that when we study about antennas, so essentially what we are doing, we are transmitting signals through antenna. And as we know that to detect any signal properly, at least so antenna length. So the first point is, why do we need modulation? So the first point is antenna length. What I'm trying to say, that we know that if we have to transmit our signal by the antenna, and ultimately signal has to be detected by antenna at the receiver end. So the theory is that to detect any signal properly, antenna length must be at least lambda by 4 length of the signal, lambda by 4 length of transmitted signal, or length of the signal. So antenna length must be lambda by 4. So you can easily see that if lambda is very large, let's say that if we have a message signal and the frequency content of this message signal is around in kilohertz, is of order of kilohertz. So we can find out lambda by the formula V is equal to N lambda, V is equal to F lambda. This is the formula where V is the speed of light, because we are talking about electromagnetic wave. So V become C, so this will become 3 into 10 to the power 8 meter per second. And we are saying that, let's say our frequency is of order of 10 to the power 3 hertz or kilohertz. So message signal has highest frequency is of order of kilohertz. In message signal, let's say that our frequency content of message signal is of order of kilohertz. So the lambda will become, if we calculate from this, so this we get 3 into 10 to the power 5, and we can write it like 3 into 10 to power 2, and then further we can write it like this. So lambda will become this. So we can say that this becomes 300 kilometer. So lambda is around 300 kilometer. So this is a very large length. So if you think of constructing an antenna of this size, then even if you take lambda by 4, this will become almost like 25 kilometer, 75 kilometer, something like that. So if you take lambda by 4, then we will get 75 kilometer. Still, this is a very long size antenna. This is a very long physical size of antenna. And so the first point, make it very clear that because our frequency or message signal is of low frequency nature, message signal is always low frequency nature. So what do? We translate it to a higher frequency. We translate our message signal to higher frequency. Translate, we'll see how do we translate, or you can say we change our message signal. We change our message signal to higher frequency. Let's say in megahertz term. So let's say that because of modulation or because of translation, now the modulated signal modulated signal is now is of order of is megahertz. So now you can see that if we calculate again lambda, then what we'll get? We'll get 3 into 10 to the power 8 and divided by 10 to the power 6. So we get around 300 meter. So this is not a very big length. I mean, this height of antennas are created in case of amplitude modulation. You may have seen radio broadcast antennas, they are very large. So you can see that because we have translated our original signal to a higher frequency, that's why the wavelength will become smaller, and that's why the antenna size will become smaller. So the first point is, at higher frequency antenna size is small. So this is the first point. We are saying that message signals, normally message signal are a small frequency messages, or you can say message signal have small frequency, and because of that the antenna size would become very large, and so we translate, or we say we modulate our signal to a higher frequency, and because of that antenna size reduced, and we can create antenna size of that length. And the second point is power radiated. This is called power radiated by antenna. Power radiated. So we have to know this, because we have not studied about antennas are taught in the higher level courses. So the theory is that the power radiated by the antenna is proportional to length of antenna and the inversely proportional to wavelength of antenna and square of that. So you can see that as 1 by lambda means as lambda gets smaller, frequency gets higher. So at higher frequency, or you can say at a given length, at a fixed length. So at a fixed length, now suppose that we have fixed our length of antenna, so you can easily see that as we reduce the lambda, what are we saying? At fixed length of antenna, let's say we have fixed our length of antenna to be L. So we can see that as lambda gets smaller, in other terms we can also say that as lambda gets smaller, frequency gets higher. So at smaller wavelength or at higher frequency, both are the same thing. At smaller frequency, at higher frequency and smaller wavelength, power radiated by the antenna is large. So for effective power radiation, we need higher frequencies, or we can say at higher frequency effective power is proportional to higher frequency. So at higher frequency effective power will be higher. That's why you can understand why it is more convenient, or why it is more acceptable to translate our original signal to higher frequency, or modulate our original message signal to a higher frequency, because the power radiated by antenna is higher in case of higher frequency. So this is the second point. And the third point is intermixing of signal. So now let's say that we at receiver end we have messages, or we have signals from many transmitter. We have signals from many transmitters, as all transmitters are transmitting at the same time. So at the receiver end, we have signal from many transmitters. So what will happen if all of these signals are in the same frequency band? So mixing, or you can understand, if you don't understand mixing, you can understand superposition as. So mixing of signals could happen. You can understand in terms of superposition that if frequencies are if the band of frequencies are very close to each other, then it is possible that the signals get intermixed. So mixing of signal could happen, and it will be hard to extract separately, and it will be hard to separate them. So what is best? We transmit signal at different band frequency. So let's say that we are transmitting at one frequency, and the band is basically bandwidth. So let's say that at one frequency, let's say that we are taking a frequency of C, and we have taken a bandwidth like this, but second signal is not at the same central bandwidth. Instead it is separated by some distance. So let's say that this is FC dash and bandwidth is this. So this signal is separate from this, so mixing will not happen. So at higher frequency, this separation can be easily done. So as long as these frequencies are away from each other, different signals from different transmitter can be received at the receiver end without mixing of the signal. So these are the 3 points that suggest why do we need modulation, or why modulation is necessary. So after that, you can ask what is modulation, or what is translation. In this case we have been seeing what is modulation. So modulation is simply, let's say that we have a message signal. This is our message signal. Message signal is low frequency, so the variation is, you can see that variation is not fast. So we can understand that message signal is low frequency, and this we represent our message signal by MT. Always we represent our message signal by MT. And what we do, because our message signal is very important, we take a stronger signal that is called carrier signal. We take a, so the issue is that, my hands get up. So the issue is that we take a high frequency carrier signal. This is message signal and this is carrier signal. As you can see the name of it, carrier. So this means that it will carry. So carrier signals carries the message signal on its back. So the carrier signal is a high frequency signal. High frequency, you can see that this is a high frequency wave. So we can represent, so what will happen, we normally, in case of analog signal, at least in case of analog message signal, analog means continuous signal and the carrier is also continuous. So what we do, we vary the, usually we take carrier signal to be, or we are saying that we usually vary carrier signal amplitude according to the message signal. Amplitude carriers what is modulation? Modulation is simply that we vary carrier signal amplitude according to the message signal, or its frequency can also be varied. Frequency, we can vary frequency, or we can vary phase. So the carrier signals amplitude is varied according to the message signal, then that modulation is called amplitude modulation, AM. Amplitude of carrier is varied according to the message signal or in relation with the message signal. That's why this kind of modulation is called amplitude modulation. And if frequency is varied, then we will call it frequency modulation. So frequency of the carrier signal is varied as per our message signal, then that kind of modulation will be called frequency modulation. And in case phase of the carrier signal is varied, then it is called phase modulation. So you can draw it that we have an amplitude modulation is like this, where amplitude becomes an envelope and higher frequency vary like this. So this is how amplitude modulation looks. And in case of frequency modulation, what will happen? Amplitude remains same, so amplitude will remain same, but frequency, where at higher amplitude frequency will become more, so this will become dense. And at lower frequency or at lower amplitude, you will see, you can understand it like this. I mean, I am not able to draw it properly, but you can understand. So you can see that this is where frequency gets higher because amplitude is higher at this point, and at this point amplitude is lower. That's why frequency gets smaller. So this is in case of frequency modulation. And phase modulation is 92 degree phase, 90 degree phase ahead or phase lags from frequency modulation. So this will become, so it is not important. We just, let's not draw it because it will be very difficult. So this is, you understand what I'm trying to say, that modulation is simply our carrier signal amplitude is changed according to the message signal, then it's called amplitude modulation. And if its frequency is changed according to our message signal, then that kind of modulation is called, or that kind of change, modulation is simply change. So we are using a very technical word, modulation, but it simply means that we are changing amplitude, then it is called amplitude modulation. If we are changing frequency of the carrier signal with as per the message signal or information of the message signal, then it is called frequency modulation. And similarly you can understand phase modulation. And we are not going to talk about digital modulation because we'll restrict ourselves to only up to amplitude modulation.